Let's go ahead and look at percent yield. So to begin, here are a few definitions. Theoretical yield is the maximum amount of product that could be produced in a reaction. Actual yield is the amount that is actually produced in a reaction. And percent yield is going to compare our actual yield to our theoretical yield to show how efficient a reaction was. And note that both theoretical yield and actual yield are measured in grams. The formula for finding percent yield is percent yield equals the actual yield divided by the theoretical yield multiplied by 100. So here's our first example. When a student conducted an experiment with baking soda and vinegar, she measured 4.1 grams of carbon dioxide were released in the air. However, going into this lab, she calculated that 5.28 grams of carbon dioxide should have been released. What was her percent yield of product in this experiment? Well, let's go ahead and look at the wording. Note the words she measured. That indicates that this actually happened. She found this in the experiment. So we know that 4.1 grams is the actual yield. The next set of words we should look at say should have been released, meaning theoretically this should have happened, but it did not. So that indicates that the 5.28 grams of CO2 is our theoretical yield. Then we're going to use our formula. Here it is again. Let's plug everything in. So we have our actual divided by our theoretical multiplied by 100, and we find that the percent yield is 78%. Now, there's a second type of problem that we can do. And this is finding percent yield when we are only given the actual yield, meaning we have to solve for the theoretical yield first. There are 3 steps to doing this. Number 1, we need to write a balanced chemical equation. Number 2, we need to find the theoretical yield. And remember, that's just a grams of X to grams of Y problem. And step 3, we'll have to actually plug in those values to our percent yield formula and solve. So let's do that now. In example 2, if 75 grams of CO reacts with hydrogen gas to produce an experimental value of 68.4 grams of CH3OH, what is the percent yield of CH3OH? So let's go ahead and look at what we have. We are looking at a product when we talk about percent yield. So we see that CO reacted with hydrogen gas to produce this many grams of CH3OH. So we know that this value is our actual yield. And we know that because the problem says an experimental value. It is something that was done in an experiment, and we found that this is the actual amount that was produced. So now we need to follow our steps because we don't have the theoretical yield. Yes, we're told 75 grams of CO, but we are working with CH3OH, not CO. So step 1, let's go ahead and write a balanced chemical equation. It would look like this. CO plus hydrogen gas produces CH3OH, and it's already balanced. Step 2, let's find the theoretical yield. Remember, this is just a grams of X to grams of Y problem. So we have 75 grams of CO, and we want to know how many grams of CH3OH we theoretically could have produced. Let's go ahead and get our table, and I've already plugged in the value I started with, 75 grams of CO. Okay, so our first step is to convert grams of CO to moles of CO by dividing by molar mass. Step 2 is to use that mole ratio from the problem, and we have a 1 in front of CO and a 1 in front of CH3OH. And finally, we need to convert moles of CH3OH back to grams of CH3OH. To do that, we just multiply by the molar mass of CH3OH. When we solve, we'll find 86 grams of CH3OH, but we're not done yet. This is our theoretical yield. So now we can plug everything into the formula. Okay, so step 3. Here it is. We have our actual yield, which we got from the problem, and we just calculated our theoretical yield. We're going to multiply that by 100 to find a percent yield of 80, which is not bad at all. Thank y'all for watching.